You know, almost every single piece of technology you use, from the phone in your pocket to the software running in your car, has a secret ingredient. Today, we're going to pull back the curtain on that secret, the C programming language. We'll explore why this code, which is decades old, is still the absolute bedrock of our digital world.
Okay, so that's a fair question, right? In a world full of shiny new programming languages, why would we even look back to the 1970s? You might be picturing C as some kind of vintage car, but honestly, it's more like the fundamental engine design that still powers today's supercars. The reason it's stuck around for so long, well, it's not a secret, but it's something we all kind of take for granted. Because C isn't some dusty relic. It's the invisible architecture holding up our entire digital world. Your Mac, your Windows PC, their core is built with C. That little computer that controls your microwave or your car's engine, yup, that's C. It's so foundational that other huge languages like C++ and Java were built on top of its ideas. And for anything that needs raw, blistering speed, we're talking the Linux kernel or the engine behind a blockbuster video game, C is still the undisputed champ.
So, where do we even begin? Well, pretty much every programmer's journey starts with one simple goal: just getting the computer to say hello. It sounds almost laughably basic, I know, but this very first step actually shows us a fundamental process that makes every single C program work. Now, here's where it gets really interesting. You can't just write C code and expect the computer to get it. Your code, the stuff you type, is for human eyes. To the computer's processor, it's just gibberish. You need a translator. And in the world of C, that translator is called a compiler. The whole process is this clear three-step journey. First, you write your instructions in a simple text file. Second, you hand that file over to the compiler, which translates it into the machine's native language. And third, you run that new compiled file and boom, your program springs to life. Okay, so now that we get the journey from code to an actual running program, let's learn a little bit of the language itself. And just like any spoken language, C has grammar. We're going to start with its nouns, the variables we use to store and manage all our information. The easiest way to think of a variable is just as a labeled box inside your computer's memory. You give the box a name, let's say age, and then you put something inside it, like the number 22. The key thing here is that you can always change what's inside that box later on. But C has a very strict rule. Before you can ever use one of these boxes, you have to declare what type of stuff it's going to hold. Are you storing a whole number? That's an int. A number with a decimal point? That's a float. Or just a single letter? That's a char. This step is not optional. You have to tell C what to expect. And here's a super important point about naming your variables. C is case sensitive. That means a variable you name age with a lowercase a is a completely separate, different box from another one named age with a capital A. This is a classic trip up for beginners, so it's definitely one to remember. So if variables are the nouns of C, then operators are the verbs. They're the symbols that let you actually do things with your data. You can add them, subtract them, compare them. These are the action words that make your code come alive. So far, any program we'd write would just run straight from top to bottom, one line after another. But that's not very intelligent, is it? The real magic happens when we can control the flow, letting our code make decisions and react differently depending on the situation. And the two main ways we do this are with if-else statements and loops. An if-else is like a fork in the road. If some condition is true, go left. If not, go right. A for loop, on the other hand, is like running laps around a track. It just repeats a set of instructions over and over again until its job is done. Let's just quickly trace the journey of a for loop. First, you set up a counter. Let's say we started at 1. Then you test a condition. Has our counter gone past its target, like 5? If not, the code inside the loop runs. After it runs, you update the counter, and the whole cycle starts all over again with the test. It's this simple but powerful rhythm that lets us automate all kinds of tasks. So, as you start building more complicated logic, your code can get messy and fast. It can become a real tangled mess of instructions. To stop that from happening, C gives us some really powerful tools for organization, which let us package our code into clean, reusable blocks. The most important organizational tool by far is the function. Think of the function like a recipe for a very specific task, say, calculate the area of a circle. Instead of writing out all the steps every single time, you just define the recipe once, and then you call it by name whenever you need it. It keeps your code so much cleaner and easier to manage. But what if you need to bundle different types of data together? For that, C gives us structures, or structs. A struct basically lets you create your own custom data type. For example, you could define a student struct that groups together a name, a roll number, and a GPA, all into one neat little package.
All right, we've covered the basics, but we still haven't touched on what truly makes C so incredibly powerful and so fast. This is the feature that really gives C its legendary status among programmers.
Now, to understand C's superpower, you first have to know that most modern languages, like Python or Java, handle all the computer's memory for you. They have this automatic garbage collection that cleans up memory you're not using anymore. It's a really helpful safety net.
C doesn't have that safety net. So what does it have instead? What gives it the raw ability to be so unbelievably fast and efficient that it can run on everything from a supercomputer to a toaster?
The answer is direct memory control. And the perfect example is a function called malloc. It's basically like walking right up to the computer's operating system and saying, hey, I need exactly this many bytes of memory and I need it right now. And the system doesn't just give you the memory, it hands you the keys to that specific address in memory. It's now completely yours to control. So here's the bottom line. C's superpower is that it trusts you, the programmer, completely. It hands you the keys to the hardware. Now, this lets you write incredibly optimized, efficient code. But it also means you're responsible for giving those keys back when you're done. If you forget, you create bugs called memory leaks that can crash everything. It's ultimate power, but with ultimate responsibility. So there you have it. We've gone from a simple hello all the way to the very core of what gives C its power. Direct, unfiltered control over the machine. These are the fundamental building blocks, not just of a single program, but of our entire digital infrastructure. So the real question isn't just what will you build, but how will you use this power to build something efficient, fast, and truly foundational?